So it is my pleasure now to introduce Vienna Lam, PhD student in the Department or School of Criminology at Simon Fraser University. Vienna.
Thank you so much for the introductions. I would also like to reverberate the land acknowledgement. So at Simon Fraser University, we live, work, and play on the unceded ancestral lands of the Coast Salish peoples. And this is specifically the shared territories of the Squamish, Tsleil-Waututh, and Musqueam First Nations. And some of my field work actually takes place on Kansi and Kwantlen First Nations land as well. And I've highlighted the word unceded because these lands were never lawfully given away. And I think it's really important for us to do these acknowledgements because they help us commemorate Indigenous peoples' principal kinship to the land. And it's also a first step towards reconciliation by honoring the original occupants of these shared spaces. So if you have any questions about any of these things or even about what I'm about to share with you, feel free to put them in the chat room and I'll try to either address it along the way or we can also talk about it at the end during the discussion period. Okay, so again, my name is Vienna Lam and I'm a PhD student at the School of Criminology. At the School of Criminology, we actually do a wide range of different things and different topics. And my particular area of interest deals with how bones are used in legal institutions, so in our criminal justice system. But when I tell people that I work at the Center for Forensic Research, their first thought is CSI. You know, it's so notorious. There are so many decades worth of episodes and new shows are popping up all the time. And in these shows, oftentimes you'll have one or, a handful of people that do a bunch of different things. They're both apprehending suspects, they're interviewing them, they're trying to figure out who the deceased person was. So they're, trying to find an identity for these bodies. They're also performing autopsies. They're examining the body and looking for evidence, on the surface of the body, as well as taking samples from inside during an autopsy. And then they go into a lab and they analyze all this, miraculous evidence, put it together. And in some shows, they're even a lawyer. So they're out there prosecuting people and presenting this evidence in court, either as an expert witness or, as a prosecutor. But in real life, this doesn't happen, and it certainly doesn't happen all within 30 minutes. So what we really have is a huge network of people working together. Police officers are normally the ones that actually deal with securing the crime scene. They're the ones that are first on the scene before anyone else arrives. They're the ones that will collect physical evidence. So that's, that may be weapons, prescription drugs, whatever that may be. And the coroners and medical examiners, in BC we have coroners, they're the ones that are tasked with trying to figure out who this person was. So they're the one that is actually trying to figure out not only the identity of this person, but their medical background. What's their medical history? Who do they affiliate with? What happened? And their primary job is to figure out what happened in this death, not just in terms of whether it was a homicide or suicide or make those distinctions, but also figure out what they're going to put in a death certificate and what the mechanism of death is. So what objects were used or what actually led to their death. Apologies for the sirens in the background. I'm just going to pause for a second. I believe there has been a recent car accident, so there's been sirens all day. Okay, I think they're good now. Next, we have medical pathologists, and these are trained medical doctors that work at hospitals, and they're the ones that will actually examine the exterior of the body as well as do the autopsy and take samples for toxicology, which is trying to figure out if this person who has died was intoxicated or had consumed any drugs prior to death. And then we have forensic scientists and technicians, and those are the people that are actually going to analyze the pieces of evidence that the police officers collected from the crime scene, analyze anything that the coroners discovered, as well as take all the samples collected by the pathologists and actually test them. And then there's a huge assortment of other people that make this entire system work, whether they're mortuary techs, they're the people, transporting the bodies. These are the frontline people that actually make this entire system happen. And so it's never, the job of one person, let alone, 5 or what have you in these TV shows. It's really a massive group of people that makes this all possible. So forensic sciences is essentially the application of any science to legal matters. So this has to deal with, this covers all types. This could include forensic accounting, computer science. It can consider things like psychiatry. Really, any application to law would be considered as a forensic science. And at the Center for Forensic Research, we don't do it all, but we do 5 things really well. So we actually have a dedicated lab specifically looking at the insects that attend crime scenes. They're your very first witness. When someone dies, what are the insects that show up? And today I'm actually going to talk a little more about how we use insects as evidence of different things. We also have a histology lab, so that lab primarily looks at isotopes and the most smallest, units of what we can observe in our bones to figure out, what changes may have happened. We also have another anthropology lab that has some really cool research on doing juvenile age estimation work, so trying to figure out how old these people are. This is particularly important when you're dealing with migrant deaths or deaths of undocumented persons, because there may be few indicators of how old this person is. We also have ancient DNA and wildlife lab, so they deal with wildlife trafficking as well as trying to apply the techniques used in ancient DNA to modern damaged DNA. So if you have a car fire and someone tries to get rid of a body, can you still get DNA using these highly sensitive techniques? One of the cool things they're working on is Amelia Earhart's DNA. So body was found, in the South Pacific, and actually a student at SFU, his grandparents inherited he inherited some letters from his grandparents that they believed that Amelia Earhart had sealed with her own saliva. And so part of their job is now to try to extract that DNA without damaging it. And we also have a lab that deals with pollen and microfossils. So I'm not sure how many of you are driving, but a lot of folks don't clean their car filter. And one of the interesting things is that when your car is driving through, especially in BC, where we have lots of lush greenery and wildlife, there's actually little particles, pollen and microfossils that get sucked into your car's filter. And you can actually try to figure out, okay, well, this person claims they were never in Kelowna, they live in Vancouver, but your car filter suggests otherwise. It suggests that you've actually been to these areas and quite recently, based on looking at these types of evidence. So it's really quite multifaceted. And this is actually our facility in our lab. Let me pull up the laser pointer. So that's actually where I work. So it's a really beautiful space. We actually have all our criminology courses. A lot of the tutorials actually happen right above. And this is where we're located. And the cool thing about this center and this building even, this facility was built with forensic evidence storage capabilities in mind. And so that means that when, there was that massive power outage a couple years ago, we still had power. And so I would have to, hustle in and try to charge everybody's laptops and phones. But it's really quite interesting because they had to build this knowing that we had to be a certain security level in order for the RCMP and other police agencies to trust us to hold and analyze evidence. And so we have steel reinforced walls, bulletproof glass. Nobody's going to be able to shoot their way in. And this also means that it's the safest place to be if we ever have a zombie apocalypse. So feel free to come knocking and be like, remember me from the FASS lectures? I'm sure we'll have more than enough food to share with what we're feeding our insects. So yeah. And what I do at the Center for Forensic Research is body decomposition. So I primarily look at bones, not so much in the soft tissue part of things, but the questions that I'm trying to answer with my research to help this network of investigators figure out what happened is to, one, figure out where this body has been based on the changes that you observe in these bones that you recover from water. And two, how long has it been there? Because when you lose all that soft tissue, you don't really get a lot of insect activity because the body's submerged below water. You're really limited as to what type of evidence you can look at to figure out how long has this body been here. And so I do that by actually looking at structural changes. And so a couple years ago, I convinced UBC to loan me a lake. And this is a short video about, just to give you an idea of what fieldwork looks like. And that's actually us at the dock. And you see all these little white markers, that's actually all the different cages. So I had deployed animal bone to study what changes will happen. And underneath that arrow is 5 of us to give you an idea of the absolute magnitude of this lake. It was massive. And so every single month, I would actually invite a couple undergraduate students through our lab. So these are lab volunteers and work study students. And together we'd head out to this remote lake where we'd recover bones, and they got to see every step of that research process. Everything from, the setup that was done to, the analysis and what we were able to do afterwards. So after picking up all these bones and rowing across this lake, I'd bring them back to the Center for Forensic Research, where I put them under high-powered microscopes and try to figure out what changes are happening on a month-to-month basis. And one of the really exciting things we discovered was that there are seasonal changes that can help us break it down to whether or not a body has been submerged for at least a year. So on the top part of the screen, you'll see what we call a reversion canal, and this is actually normal. This is just a normal hole that we have across our bones. Our bones are kind of like sponges. They have all these holes that nutrients can come in and take waste out. And what's happening is that microorganisms that live in our water are able to penetrate deep into the bone, and they'll eat all that soft tissue away. So they'll take that away, and then the water will still be there. And what happens in winter is that freezes. And then during spring, when it thaws, it cracks because it expands. And it creates all these tiny little cracks that help give us an indicator of, hey, this body, it's hard to tell how long it's been there, but at least we can say it's been there for at least the winter. And that's just one of the things we'll look at. Other things include, the type of, there's shellfish in the lake. And so these freshwater mollusks, like clams and mussels, what have you, they'll actually also eat soft tissue, and they'll spit out garbage in the surrounding dirt. So that also gives us some indicators of what's going on. And this is just like one of, 15 things we'll be examining. And our lab is actually one of the few that facilitate teaching. So part of my job is to help teach some of the forensic courses. And at the Center for Forensic Research, our forensic entomology lab will always have tutorials between semesters. So we'll actually have students come in and they'll do dissections of insects. And the most important thing is a lot of those focus on how that's applied in jurisprudence. So how that's applied in court, how is evidence being interpreted, and what can it say? Because a lot of these shows often make really grand claims. So we try to dispel those myths. And through the School of Criminology, we offer a number of different courses. So everybody does take that first Crim 355 forensic science, and that's the one that gives you a really broad scope of what forensics is, what are some of the many types of forensic disciplines you can go into. And then you actually get to choose what other types of courses you want in order to supplement that knowledge. And anyone can tack on a certificate. You don't have to be a crim major. You could be in poli-sci or psychology. And we actually get that quite often where students have one major, but they'll still be interested in taking the certificate. So one of the things I also get asked about a lot is how I got into this. So it all started off with me doing a field school through SFU, where I went to the islands of Fiji. You know, what a better way to actually be able to bring your classroom outdoor. And so there I learned about past human health, I learned about human osteology, and that's what really sparked my interest in understanding human skeletons and how that can be applied to law. And soon after, that actually turned into a job. So I ended up being one of the lab managers in the field for the Fiji and the Kingdom of Tonga field schools. And it's really quite a magical experience to be able to apply what you learn into the real world. Because it was in the Kingdom of Tonga also where, you know, I was first exposed to how people interpret information and how information is even being constructed and who gets to tell those stories. And so that's a lot of things that we discuss a lot in our courses. One of the things I did want to mention about Kingdom of Tonga is we were digging in this mangrove swamp. And one of the things we didn't expect was the sudden smell of vanilla. I don't know if you've ever smelled fresh vanilla, but the mangrove swamp is absolutely, you know, filled with wild vanilla, like thousands of dollars worth of vanilla pods, just, you know, growing everywhere. And it's one of the most magical smells I have ever encountered. And the thing about schooling in these terms is that you kind of have to be up for anything. So one of the other things we didn't quite anticipate was the number of wild boars and pigs that would try to wander into where we were doing our classes and where we were doing our dig. So one student's job a day was just really to chase out the pigs. So they would have to make sure like they're not eating our lunch or stealing our gear. I end up having a pretty good relationship with them. I'll give them my coconut husk at the end of the day if they don't mess up anything. So they learned pretty quick. They're pretty smart creatures. And yeah, so yeah, your schooling through SFU programs can really take you to a variety of really interesting places. And at the end, I'd love to show you actually the list of different destinations. So SFU actually has partnerships with more than 150, I think was the last count, of different universities that you can do an exchange in. So it's pretty cool. Okay, so back to Center for Forensic Research. I did promise that I would talk about forensic entomology. So a little more about what it is that our lab does. Because other than teaching, other than research, we also do casework. And so casework is when we're actually helping police agencies and, you know, the RCMP or even, you know, wrongful conviction cases in the, you know, around the world, figure out what happened and try to provide a timestamp for when something happened. And by timestamp, I do mean a range. It's never a set time. Like TV shows will always say, oh, this person died at 12:55. That's really hard to get to unless if, you know, there's some video evidence of some sort. Okay, so insects and death. Well, what can insects tell us? The first thing is it helps us determine a minimum postmortem interval. And what that is the minimum amount of time it would, you know, this body must have been here for, or since the body has died. Because insects, the ones we're interested in anyways, they only eat dead tissue. Right? They're not interested in the living. And so the person must have died, or you have some type of necrotic tissue on you while you're alive before they'll be interested in laying their eggs. They can also help us determine movement of a body. So say if, you know, you knock someone over the head in your backyard, don't know what to do with the body. So you bring them down to your basement, and then, you know, later at some point you wrap them up, put them in your trunk, and drive out, you know, to the remote wilderness and dump the body. If that body is then found, you can compare the types of insects that are on the body, because the type of insects you'll get in, you know, where we live in the urban city, it differs so much than what you'll find, you know, just half an hour drive away. And there's also pockets of changes, pockets of different types of insects that live in these different regions. So that's a really big part of what we do. There's also cases where they can provide us information about the types of drugs a person may have consumed. So if you're, taking methamphetamines, or, you had cocaine before you died, before it fully metabolizes in your system, insects are already eating and feeding on you. And so those drugs end up in the insects. And so you can extract that and also get some information, because I can assure you these insects are not particularly interested in cocaine. They're not flying to them to try to consume them. It only really gets in their system if, whatever they are feeding on has it already. And so this becomes particularly important in cases where there are no witnesses, and you may be dealing with a car accident, for instance, and there's the body is highly decomposed. You can try to get some information about whether or not that person was drinking based on the insects on the body. And also presence of wounds. So when these blowflies, they lay their eggs on you, they're not going to do it in a place that's not moist and easy to break down. Because when their eggs first hatch into first instar larvae, they don't have mouths. Just like human babies, they can't break down food immediately. They don't have the necessary, teeth in order to break down those substances. That's why adult flies will often target places like your eyes, your nose, your mouth, your ears, or those type of locations, because it's already, moist, open. There's other type of, softer food sources that their babies can consume. So if you see a bunch of, insect activity around the stomach, that's highly peculiar. Normally that's closed, and it would be really unusual for blowflies to want to lay eggs there, because their babies can't eat anything that's there. So that will often be a good indicator that actually something happened in that area, that there's some type of trauma, some type of skin puncture. There must be some type of blood or moisture. And we rely on two methods to gather that type of information. Both successional colonization, which refers to the types of insects that are landing on the body and how old that individual insect is, so of that species. So some insects, they, like bodies, really fresh. They're the first to the crime scene. They're first because they don't like it when it's too decayed. Whereas some insects, they actually like feeding on those early guys. So they won't come until later. They'll wait until the eggs are all laid and they're a little bigger and juicier before they come around. So they also are pretty picky eaters. So that helps. And the main principle that this is based on, for blowflies anyways, which is what we study, is that they are poikilothermic, which means that their internal temperature is based on the surrounding environment. Unlike us humans that are homeotherms, that we can regulate our temperature, blowflies, their metabolism will actually change depending on how warm or cold they are. And if they're too cool, they actually slow down how fast they grow. And depending on how much time it takes them to reach a certain age, that is what tells us how much time has passed since the body has been there. So this is just a brief slide to depict what happens. So these adults will lay eggs. They'll hatch into first, second, and third instar. And then once they're done feeding, they will actually crawl away, and then they'll pupate before re-emerging as adult flies. So similar to caterpillars that create a chrysalis before emerging as a butterfly, they do the same thing. And with that, I'm going to actually share one of the cases that has been closed. I'm not allowed to share any active cases with you. And so I do ask that everyone please don't film. And I'd like to take a quick break in case if anybody does want to indicate that they want to be put in a waiting room. I want to make sure you have a chance to do that. Don't worry, we'll bring you back for the discussion at the end. And so we've covered that case. And I'd really like to highlight one of the strengths of this program. So at the School of Criminology, you're not just learning about the theory that goes into what you do, you actually get an opportunity to put yourself in the field. And so with our School of Criminology field practice program, you get the opportunity to actually work with local agencies, whether it's the SPCA or, John Howard Society or some of, the law firms that are local to the Lower Mainland. You get to get a sense of what your life could be like after you're done your degree. And I really want to highlight that criminology may not be for everyone because you're really dealing with some of the toughest topics. You're studying some of the most heinous crimes against humanity, human right, animal right abuse, and violations. But the thing is, if you want to make a difference, I genuinely believe that criminology is a great place to take that first step. So our field practice program, you can find more information here, and it comes as both either a part-time or a full-time option. And back to the Forensic Entomology Lab, the School of Criminology is really lucky in that we have a really incredible roster of world-class, experts that are actually teaching you these courses. In our case, Dr. Gail Anderson, she's one of 20 American board forensic entomologists that are board certified in the world. And so we actually get to, receive evidence and learn about how insects can be applied to all stages of that criminal investigation. And as an honor student or undergrad student, that's when you'll start getting exposed to it. And if you're interested in actually going on and doing your honors as an undergraduate student, you'll get the opportunity to run your own research. And just to give you an idea of the breadth of topics, even just within our own little research group, it's extremely varied. With Samantha, for instance, she just came back from spending 6 months in Kenya chasing down poachers. And if there's anyone who might get shot, we thought it'd be her because she's, riding in the back of jeeps, chasing down these animal poachers. But that was with the United Nations, and that's such an incredible opportunity. And then you have people like Soraya, who's working with, innocence projects, looking at wrongful convictions, looking at how jury members or lawyers or judges are interpreting evidence. And so forensic science is not just what you imagine, taking place in a laboratory setting. It's really, it permeates a lot of our life, and it's, so deeply ingrained in a lot of different things that we do. And there's so many ways to go about pursuing forensics. I really encourage you to just speak to people, attend, the forensic symposium, go online, check out, professional affiliations like the Canadian Society of Forensic Science or the American Academy of Forensic Sciences. Like, these are all organizations that help support the application of whatever topic it is, dentistry or psychology or law, in these types of matters into investigations. And with that, I'd like to thank you for joining us today. And if you have any questions, feel free to reach me at vienna_lam@sfu.ca. Thank you.